Saxon's Calculus Lesson 20, the parabola as a locus, and then translated parabolas. They remind you at the beginning of this lesson that the one way to write the function formula is to say something like negative 2x squared minus 4x plus 1. But to graph it, it needs to be in a format that is a parenthesis squared with the x plus 1 and then the plus 3. And when it is in this format, the vertex point is negative 1, change the sign pulling out of a parenthesis, not in a parenthesis, so don't change the sign. So negative 1, 3 is the vertex point. This negative would tell me that, oh, I left the equal sign off. The negative would tell me that the parabola is opening down, and the 2 would have to do with how wide it was or not wide it is. So then the other pieces that we learned last year was that we can have a focus dot that is the place somewhere inside the parabola where every distance that you can possibly go, it's the same both directions. And then whatever the gap from the vertex point to the focus point is, so if that were like 2 units, then if you go 2 units the other way, you are creating what we call the directrix line. And so in the box on the bottom of 111, it says a parabola is the locus of all the points in a plane that are equidistant from a given line and a given point. So they're equally distant from this directrix line and the focus point. This dot is the same distance here as you would have mirror image here. Okay, the line is called the directrix and the point is called the focus. Now, on 112, page 112, they remind you about the distance formula and how we can use it to create, and we did this before in trig class. So basically, you are manipulating the formula until you get to this fraction 1 over 4p. And that 1 over 4p is your, I need to back this up. HK is usually my center. HK plus P is my focus point, vertex point, focus point. Then this 1 over 4P is the equation P. So it's 1 over 4P x squared. And so I can use this given information to be plugging into the formula to help me graph and so forth. There is a new piece of information in this book in calculus which says, and it is the bolded words just before example 1, it is interesting to note that the width of the parabola at the focus point is the absolute value, so whatever this distance is, that is the same as you get when you take the absolute value of just 4p, and we call that the latus rectum. And they're going to begin to give you that piece of information as part of graphing parabolas. So in example 1, the equation of a parabola is y squared equals negative 8x. Sketch the parabola and give the coordinates of the focus, the equation of the directrix, and the length of the latus rectum. Okay, so it wants it graphed. Since this doesn't have a parenthesis part, I realize that, and there's no other number attached with the y or over here. My center point is therefore at 0, 0. And then my negative means that I am opening it negatively, but I also realize that my y is being squared, not my x, and I'm used to seeing it that way. So this means that it is a flipped sideways one, so it's not opening positively, it's opening negatively. So that part I can get just from generalizing what they gave me. Now, if I use the formula 1 over 4p equals the negative 8, then I can find 1 equals negative I realized what I was doing wrong here. I'm so used to solving it with the square not being attached with my y. So let me fix that so I can so I need to have the x alone before I can use that formula, because otherwise I'm not in the right format. So x will equal y squared over top of, or I'm just going to write 1 over the -8. So -1/8 y squared. I like that better. Okay, so then 1 over 4p should equal the 1 over -8. So basically 4p equals the -8. And then p will be -2. Okay, so my vertex point we've already said is 0, 0. My focus point should be at 0, 0 plus p, so 0, so the focus point should be at 0, -2. Here is the focus point. And then I know that the directrix line is the same, but the opposite direction. So my directrix line is here. I guess I should label that my focus point. I think they wanted that listed. And then the directrix would be, oh, no, again, did it backwards. It's x equals, because it's crossing the x line at 2. So the directrix line is at x equals 2. Now, what else do they want? Sketch the parabola. We've not quite finished that yet. Give the coordinate of the focus, done. The equation of the directrix, done. And the length of the latus rectum. So at its widest point, and so usually what we would do before to get another point to graph is that I would pick another point and plug it in and actually solve for it. But since we're going to use the latus rectum, which has to be the absolute value of 4p, so that took us back to here at -8. Its absolute value is 8. Well, that tells me that from this focus point, I need to be going 4 in both directions. And so there is the mirror image point that I need to graph the parabola. Now I've finished with the graph, and I can label that the latus rectum is 8. And that should be answering all of the parts that it wanted. Now, in part B, this center they left at 0, 0. Now they're going to talk about what happens when we translate it or we move it. So they're giving us x squared minus 4x minus 8y minus 12 equals 0. So my squared is with the x. That tells me I need to solve for the y to put it in the correct format. So -8y, oh, wait a minute. Goodness, I'm having more trouble. Let's leave the x squared and the minus 4x on this side. Let's move this one over, making it 8y. And then I know I'm heading to a completing of the square, so I'm going to temporarily move that plus 12 over here so that I can do the completing of the square. So that gives me x was squared, so we remember that it is half of the x term, that's -2, squares to 4, and adds to the other side, which makes 16, which moves back over, making it -16 equals 8y. And the final step is to divide everything by 8. So we get y equals 1/8 x minus 2 squared. And -16 divided by 8 is -2. Oh, I was looking for their equation to make sure I didn't have any problems in here. Oh, they've left that 8 on the other side. You know what? I like this. It's fine. Okay, so now in the directions, it says, that was the equation, sketch the parabola. So the center point is going to be at +2, -2. Change the sign coming out of the parenthesis. That's my vertex point. It's going to be opening upward because this is positive. The 1/8 is actually going to make it relatively wide. I know that. And then coordinate up, no, back on example 1 again. Focus and directrix and okay, so they want all of these things labeled. All right, so my 1/8 would equal the 1/4p, so that 8 equals 4p again. P is 2. That means that the absolute value of 4 times 2 is 8. The absolute value of that is 8. So my latus rectum is 8. That's off the focus point though. My focus point is K plus P. Now I know the P is 2. So the vertex point, I didn't list it. Vertex is 2, -2. That makes my focus point 2, and then K plus P. So it's what plus 2, my K at -2. -2 plus the 2 is 0. There's my focus point. So 2 over and 0. Here's the focus labeled. And then I know that I need to have 4 that direction and 4 that direction to have the full latus rectum. So 1, 2, 3, 4. 1, 2, 3, 4. And I said it would be fairly wide. Okay, so there's the parabola graph. Focus, vertex are labeled. Latus rectum is 8. I don't know if I want to put it on my graph. And the only other thing is the directrix. This is 2 away from the vertex point, so 2 the other direction makes that the directrix line. All right, flipping the page to 114. Oh, I guess they did actually. Okay, so they tried to do this and labeled it and said, oh yeah, that's 8. And they were more specific. The absolute value for P is 8, but you get the idea. Okay, finally, example 3. Find the equation of the parabola whose directrix is x is -4. That's the directrix. And whose focus is at 2, 1. 2, 1 is the focus point. Find the equation of it. So I don't know my H and my K. I know that my focus point is H and K plus P. And if this is x equals -4, I was wondering if I could count that up the other direction. I see that my directrix line is crossing the x-axis at -4, which tells me then that it's opening sideways. So my y is going to be squared. So my 1 over 4p is with my y squared, and it needs to equal my x. And technically then it's x minus h and y minus k in the parentheses squared here. Now, so even though I wasn't going to do my graph, I feel like it is going to help me here because my focus point is at 2, 1. And I know that the vertex point has to fall halfway between them. So that's probably the best way to find my HK. So 1, 2, 3, 4, 5, 6 is the distance. So 3, 1, 2, 3 would put my vertex point here at -1, 1. So now I could fill in x plus 1, because I put it in a parenthesis, equals 1 over 4p, and my y minus 1 being squared, because it went out of a parenthesis. And then to find the p, I'm going to use my k plus p equaled 1, and then my k was 1. Oh, wait. -1, 1. Something's wrong. I think I did this backwards. Hold that thought. I am labeling it backwards because the y is what is squared. This should be h plus k p, and the hk is correct. This is where I'm derailing. So it should be 2 plus k equals, still don't like it. Oh dear. Okay, yes, my original h is not 2, it's -1. Good gravy. -1 plus what is 2? Ha, now we're getting there. K equals 3. Okay, K plus P. Oh, good grief. HK is the original. This is H plus P. P equals 3. My goodness, I'm so sorry. So P equals 3. Now we're there. Now I can plug this in. So I have my x plus 1 equals my 1/12 with my y minus 1 squared. And again, I have this, I've attached it, out of instinct, I've attached it with the y, but the formula has it attached with the x. So it should be multiplying everything by 12. So I'm just going to change this from its fraction format to its other. So now the 12 is attached correctly with the y section. All right, we have now y minus 1 squared (1/12) here, moved it over, makes the 12 with the x plus 1. Oh, finally, okie dokie. Equation, got it. That's all they want. Mercy, hard fought. Okay, so let me just clarify one more time that this does not confuse you. I am going to keep my 1/4p with my squared part. That came out 1/12, but I don't want it with my squared part. I want it over here with my x, so I multiply by 12 and put it over here. You know what? You could have argued either way. You could have been acceptable. They're flipping it because it's graphing sideways.